In this video, I'm going to continue on the garage door control logic, which is covered by the previous video. Right. So from there, we have the first design. I call that version 1. So you can see here, I'm calling the version 1. I'm using a different window. Right. So that's the logic we get from the previous video. So we designed that. So first, let me review the function. Alright, right now the door is ajar and stopped, so I can press up button and you can see motor moving up. Right, that's the logic design behind it. And if I press down, right now if I press down button, you can see nothing happen. Right, because you can see here this is being bypassed by motor up. So even though I press the button, this becomes false, and that doesn't affect any result on the output. Right? And also because the interlock, there's no way I can energize the motor down. So you can look at that one more time. Right? So that's what we have. Right? So if you want to stop the motor, stop the door, or change direction, you have to press stop button first. Because the stop button control both directions, right? So right now motor stopped. Then if I press down again, I can change direction to the other way. So that's the current function we have with this logic. Nothing wrong with this one, and it's just what we have for this right now, right? So vice versa, when it's moving down, if I press up button, nothing gonna happen, right? So it's just like a not response, right? So you have to stop and then press up button to change that to the up direction, right? So you understand what I'm saying now? Okay, so for example, for fun, all right, so it's just we don't have to, but I want to introduce a new instruction, a latch unlatch. All right, so we want to have some new features on the existing design. So for example, like I said, when I press the opposite button, the direction, the motor should stop. So I'm going to show you what's the result. Right? So right now it's version 1. I'm going to switch to different subroutine by latch. Alright, so that's different design. So I'm calling that subroutine now. So it's not the version 1. I'm keeping this over here. It's just for comparison purpose. Alright. So by using the latch unlatch, we can have the new feature. So for example, door is stop ajar. When I press up button and motor up, it's running. Alright, so don't look at this side. This side is you can see it lose the green bar. There's no green bar on here, right? If you compare both windows, so that means this subroutine is not being running. It's not running anymore, right? It's somewhere else. I'm going to show you in a moment. So by this new logic, right now motor is moving up, and then if I press down button, watch what's gonna happen. Alright, the door stopped, but it doesn't change direction, right? It just stopped. You can see here, I release the button, it stopped. But if I press the down button for the second time, I can moving down here. Alright, so same thing again. Same thing on the opposite. If I press up, the motor should stop. Alright, it's almost like by pressing the opposite direction button, you have a second stop button. You still have a first stop button, it's working, but you can have a second stop button. Alright, of course with stop you can either change direction or you can keep going with the old direction. Before was going down, right? I can keep going. Or if I press up button, stop the door, I can go to the opposite direction, right? So alright, same thing for the down button, stop that. Alright, okay, so how do we add this new function into the existing logic? Right. So on the right hand side of my window, you can see here this is version 1, right? But right now we are calling the by latch, right? So I'm going to open this subroutine. You can see here at the moment, yeah. So I'm going to block it and to show you the design on here. So from the description I just gave to you, right, you can see that you may find a different way to do it, but the one I'm suggesting you is that if you think about with the conveyor control, I introduce a new tag called run to have the logic intermediate result. So same type of thinking we can apply on here. So what we can do is that, like I mentioned, it's almost like a second stop button. So why don't we just create a new tag called hold? You can give any name you want. This tag is not connected into any input or output. It's just a memory tag, right? So we use that to process the logic. So it's identical to the stop button. All right. So somewhere else we have to control this memory tag. So right now you can see I'm using a latch. So latch, that means similar to the OTE, right? So this is OTE. If you have a L inside, you latch it, you energize it. But if you have U inside the brackets, you unlatch it. So that's basically what it is, right? It is a sort of energizing or de-energizing, but it's different from the regular output energize. All right, so that's different video. I don't want to talk about too much about that. All right, but for now, you just understand this is what we are trying to do. So in order to make the logic working, right, so we have to find some condition. Right now I'm blocking there, right? With this condition become true, we energize the hold. When that become 1, energize logic become 1, and the exam off will become logic false, right? So tag value 1 will make this instruction become false, and that will cut off the logic continuity from here, and then you can de-energize the output. All right, so let me demonstrate that first. All right, so clear out. Let's look at here. So I can still press here. You can see press up, right? You can see motor up is energized, and hold is not energized, right? So that's why exam off is true. So when I press down button, I will energize the logic should energize the hold, like I explained before. This become logic false and cut off the power to motor up. So that's what happened. When I press down button, you can see the hold is being energized. So that's why motor up is being de-energized. Right. So that's what happened on here with this one. And same thing if I press down button, motor down is energized, and then when I press up button, I want this one energized as well, right? When that energized, so I'm going to move down here, right? So you can see this is the hold doing the second stop button thing as that, right? So if I press up button is here, right? I'm going to press the up button, and then that should energize, latch the hold, and cut off the power to the motor down. Alright, so by the explanation what I gave to you, so you understand that that's very naturally you can see here. That's the solution here. So when motor is moving up, somebody press down button, gonna latch it, energize it, and that will cut off the motor up. And parallel branch or relation, when motor is moving down and somebody press the up button either by mistake or purposely, so that will energize the hold, and same thing here, this will become false and cut off power on the down. Right? So like I said, I'm gonna explain more with the latch unlatch in different video, but for this one thing you need to know that they have to come in pair, right? So that's why we have to energize the unlatch somewhere else. So I already reviewed the answer, so you can see on here. So this little bit stretch. I found some students, some people take some time to figure out. This is the condition to de-energize, because whenever you latch it, it come always with in pair. Right, so you have to unlatch it. So the unlatch condition is that either of this button being pressed. You're gonna unlatch it in order to make the next cycle happen again. So I'm gonna clear out the drawing. So press button, you can see that again. See the operation again. So by press up button, right, motor up is energized, and then by you can see this is true, and when I press down button, this is gonna latch. Right? So you can see here, so it's latched. Then you can see the unlatch is also highlighted. That means the tag value is 1. But when I release the down button, this will take effect to make the tag value become 0. So that's basically what unlatch it is. Alright, so this is the first instruction with latch unlatch. I'll try to have more examples to explain more details with latch unlatch. Alright, so but for now I just want to talk about the relation between the latch unlatch and the seal in. Alright, so I will have to switch that again. So this time I want to call different routine. So I want to use seal in to do the same thing, similar to the latch unlatch you just see on the demo. All right, let me go back to the latch. All right, so this is seal in but not finished. All right, so I want to show you some of the design thinking here. So you can see this is hold, right? Same idea. I want to have a hold here, but this time I didn't use the latch. I'm going to try to use the OTE, regular output energize, to do the same thing by not doing the latch unlatch in the same time in the logic. All right, how do we gonna do it? So I'm going to have to do something here, right? So let me switch window here. Let me rearrange. All right. So also I would have to use one very cool feature on the emulator. So you have seen me use the emulator for a long time, right? Emulator work exactly same, almost exactly the same way as the real PLC. Plus, there's some extra features. That's what we're gonna use for the this demo. All right. So let's go back here. You can see that a similar thing. All right. We get similar thing from the latch unlatch. We create a hold, then we insert this in here. Also, we insert this in here. It's almost like the second stop button, right? So then we have to figure out the condition to energize this, right? So one thing is that when the motor moving up, somebody press down button, or when the motor is moving down, somebody press the up button, right? So that's definitely a very good start for that, but not complete. So I'm going to show you that. All right. So let's see here. If I press up, and for sure we see the move up, moving up, motor up, energized, right? This one is not on, right? So it's what happened out here. And we expect when we press the down button, the motor up will stop, right? So let's see what happened. Do you see what I'm saying right now? So motor up is de-energized, but surprisingly, we're seeing motor down being energized. So it's not exactly what we expect. So we just want to use this as a second stop button, right, to stop the motor. But instead, not only stop it going to the other direction right away. Right? If that's not what we want, we have to fix it. Right? So I'm going to release the down button now. You can see moving down is still running. Same thing for the other direction. When I press up button, I want to stop, but you can see instead it directly changed to the other direction, moving up. Alright, so what exactly happened? Alright, so we have to think about on the design, and this is a very cool feature. I'm going to demonstrate, and also again because the Latch Unlatch is related to the seal-in, so that's why we need to talk about a little bit more. And also I want to show you a very cool feature on the emulator. Emulator has a very good feature called single scan. So PLC scan is a very important concept, right? So it asks me, do you want to continue or single scan? Right? Single scan is just let the PLC to run your program only for one iteration, so one loop, and then stop. And then I change back to yes or press no, then I can move to the next scan. Right? So in this way, we can see exactly what happened. It's almost like we put PLC operation in the slow motion. So because that's the only way we can see what's going on with the existing logic. Right? So right now, the motor is moving up. Right? So I cannot press button anymore. Right? So I have to use this toggle. So for example, if somebody toggle that or press the button, right? So you can see here, I toggle it and it's simulated to press. You can see on the HMI it's being pressed. But you know, PLC right now emulator is in the single scan, so that's why you don't see the hold being energized, because you can see here according to this, the hold should be energized, but because I'm holding that single scan, it's not running the logic. All right, so I'm gonna click no, so PLC will only go through one scan to run this program only for one time. Alright, so when that happens, you will see this hold being energized. Alright, so that's what happened when I press no. You can see here, but remember, only one scan. It's just because when PLC is running very fast, we could not see what exactly happening. Alright, so now let's look at what happened out here. Alright, so motor is moving up and somebody pressed down button and the hold is being energized. The tag value is 1 now, and that will change this into false. You can see here it already loses the green bar. Right? But because I'm holding the operation, you still see the motor up energized. Right? So if I press this no again, PLC will run next scan. Right? So when PLC run next scan, you will see something happen out here. So this will be de-energized for the next scan because of this. Right? It lose the logic true. Right? So when that happens, I think you can see that, right? I hope that's the case, because the motor up is de-energized. This will lose the logic true. in turn the hold will be de-energized. Right? I am not sure if that's gonna happen in one scan. Alright, but anyway, I just want you to pay attention to this spot. I'm going to click the no. PLC will run one scan only. Alright, so you can see here, that's exactly what I expect. Alright, so this will become de-energized, and then that de-energized. And when that de-energized, you can see here, this hold become logic false. Right, so that's what happened with the next scan. But remember, the down button still being pressed. We'll look at the PLC operation in the slow motion. Right, PLC scan can go hundreds, maybe thousands times for 1 second. Right, so when you press button, PLC for sure gonna run really fast for how many, maybe hundreds of scan already. Right, so the down button is still being pressed. Then let's look at what happened next. Down button is still pressed. That's true. Hold is logic. It's 0 now. When it's 0, this is true. So you can see here, all this green bar being highlighted. Right? It's just because I'm holding the operation. So for the next scan, this motor down will become energized. It's right now is just waiting for the next scan. So that's why you don't see motor stop. Instead, it goes to the opposite direction right away. So I'm going to click the no. You will see the motor down energized. Alright, so that's exactly happened on here. That's the problem we see before. Alright, so exactly the same thing happened on the opposite direction. So now you can see how do we fix it. Right, now we're looking back to the seal in, as I explained. Right, so the problem is here. When the motor down de-energized, it cut off the power on here, and in turn cut off the logic true on the hold. But while the button being pressed, we want hold to be energized while the button being pressed, unless it's released. So that's why problem is here. So we need to add something on the motor up on here in order to hold it. So now this is the new meaning with the seal in. So I'm going to show you on here. So parallel branch, right? Seal in parallel branch on here. So we use the exam on of the output to hold the motor up. Alright, so same thing, I'm going to do the mirror image on the other side. So seal in here and finalize. So once I finalize, you will have a big run on the logic. Alright, so you can see it has two parallel branches. Within each parallel branch, you have the other parallel to seal in on here. Alright, so I'm not going to go the single scan again. That's gonna take a very long time. Alright, so this time I'm going to click yes. So when I click yes, it will go back to the continue. Alright, so we can see if the new logic will solve the problem. Alright, so now we are running continue. Alright, so if I see on here its motor is moving down, let me try the up button. Alright, right now motor down is energized. I'm gonna try this one. Press up button. When I press up, you can see we got it. The motor stopped. It didn't go to up direction, but stopped. When I release, yeah, it's still holding, right? Stopped. Alright, so when I press the up, if I press up, okay, oh, down button is still a toggle. Sorry, I forgot to toggle this back. All right, so this one is still being toggled. Right, so if I press up, should go into the up direction. Let me try again. All right, again, I forgot to this one. Remember before I used the toggle. Right, I need to toggle back. So I'm gonna demo again. All right, moving up. Right, right now moving up. If I press down, stop. I should go to stop. And after I release, and if I press second time, I go to down. When it's moving down, if I press up, I should stop, and then press again, I go to the other direction. All right, so you can rewatch this, watch again about the demo. All right, sorry about a little bit of mess up. So next question. All right. What's the difference? Why do we need a latch unlatch? As you can see, I have both solution with the latch and unlatch, right? So you can see this is the latch unlatch solution I showed you before, right? So we use latch unlatch, and this is the routine use seal in, right? Logic wise, they are identical. They are exactly the same function, right? So then you may ask, why do we need a latch unlatch if the seal in and output energize OTE can do exactly the same thing as latch unlatch? What's the point? All right, so the difference between these two type of technique is that if you latch it, that bit will be saved in some special memory in the PLC. It's backed up by the battery. As long as the PLC has battery, this bit is still energized when you have the PLC power off. Then when the PLC power back on, because of the battery backup, you still remember this bit was on before. Right? So it's like a long-term memory. So once you latch it, it's always on. Right? Even when you kill the power to the PLC, when you power back on, you still see that bit is on, right? So that has some special function in the industry controller. For example, if you want to memorize something you already did in the production, even with the power loss on the PLC, you still want the logic memorize this. You should use latch unlatch. But if you want to use to control the motor, right? I mean that like this, exactly the output on the motor, you wouldn't use the latch unlatch. Imagine if you latch the motor energized, but your PLC power off. When your PLC power off and back on again, if you latch it before, that motor gonna turn on right away. That's dangerous. You don't want to have motor turn on once you have that, right? So okay, so I think that's the end of this video. We'll talk more about latch unlatch on different video.